Now we're going to talk a little bit about resistors. So I'm going to pull out this jumper here. And I'm going to grab one of my resistors. I'm going to grab my 100 ohm resistors. So you tell how strong a resistor is by reading the bands. So that one has gold on one side, and reading from the other side it goes brown, black, brown. And you can go to a resistance table or resistance calculator to find out how effective this resistor is, how much resistance it offers. We have a whole reference on STEAMlab as to what the values are and how to read them, and with a couple of examples. So I recommend you go look at that. So I bent my resistor nice and neat up at the base. And I pulled out already my jumper, and I'm going to replace the positive with the resistor. I'm putting back another positive. Okay, so row 29 is my ground still. Row 28 is my positive with no resistor. And row 30 is my positive with a resistor. And we're going to look and see if we can figure out what the resistors do. And so I'm going to plug in the light here. And I'm going to swap it and plug it in here. And we don't see much difference. And so we're going to try that with a different resistor. And then we'll discuss what they do. I'm going to try that with my 2.2 kilo ohm resistor. And that is 3 red bands. Okay. Okay. Now let's see what happens. Oh, there, you can see that easily on the video. Okay, so that's with my 2.2 kilo ohm resistor. See if we can turn that. It almost doesn't look like it's lit from this direction. And look how bright that is. Okay, so let's talk about what resistors do real quick. Oftentimes we talk about water in order to explain electricity. So if we think about my batteries as a water tower filled up tall with water that's waiting to come goosh out, okay, that's what we talk about when we talk about how big the voltage on the batteries are. So right now we have 6 volts of power coming from these stacked batteries. If we talk about the resistor then, the resistor is like the size of the hose at the bottom of the water tower. So without the resistor, the way it is right now, we have no hose essentially. The water is just gooshing out as much as it wants to, and the LED is soaking up as much as it can. Now, if we were using a larger power source, our LED could burn up because of that, okay? It could break because it just had too much power rushing at it. It's not going to break with anything we do with batteries, so we don't need resistance for it. But if you plug things into your wall, you need resistance in order to keep them from just getting blown away by the electricity that's coming at them. Now, if we swap this and put it on the side with the resistor is acting like a hose that's constricting the amount of water that can come through. Okay? Now, the important thing to note is that the resistor doesn't limit the specific amount of water that can come through. It limits how quickly the water can come from the water tower. So if there's not much water in the water tower, if there's not much pressure at all, okay, then there still won't be much pressure coming out when there's no resistance. And the hose will make there be even less water. So the resistors don't say only 1 volt of electricity can come through, okay? They say only this % of the electricity we have available can come through. And that's a very different thing. So we're going to do some experiments with that. That's why we wanted a different type of battery. So now I'm going to I'm going to zoom out for a moment so we can see what I'm doing. I'm going to unplug my coin cell batteries that we've been playing with. So that was 6 volts of power. Instead of using both batteries together, I'm just going to use one. Okay. I need to add my tape back. Hook my clips up to the right sides. There we go. Okay, let's zoom back in and see what our resistor does to this one. Oh, that's even dimmer than it was before. Okay? So that's hard to see at all. Now, you can add the values of resistors. I can take this resistor. Actually, let's take a smaller one so we can see more. This is our 100 resistor, 100 ohm resistor. Okay, we can see that makes more of a difference with just our 3 volt battery than it did with our 6 volts of power. And so now I can stack these resistors if I want. Let's get rid of this jumper right here. Now let's do a quick experiment. By stacking, I mean chain one after another. So I'm going to add this 2.2 kilo ohm resistor to the end of this 100 ohm resistor. Its legs aren't cooperating with me. Okay, and then I'm going to put my battery there, or my LED at the end. And look what happened. It's lighting as if the 2.2K resistor, kilo ohm resistor, isn't even there. And it's not. I can pull it out and nothing happens. And the reason is, remember I told you that this resistor here powers this entire column. And so it was just bypassing the 2.2 kilo ohm resistor and going straight to the LED. There was no reason for the power to have to go through it, the resistor, before getting to the LED. So that's something you want to check when your projects aren't going quite the way you want to. So now I'm going to change that up. I'm going to add a 220 resistor so we can actually see the difference. So I bent the legs down. And I'm taking that from 30 to 28. Remember, I removed the jumper from 28. So now the power is going all the way down the positive here through this resistor to 30. So that's a 100 ohm resistor to column 30. Down column 30 and up the 220 ohm resistor over to column 28. So we've just added those resistors, and I'm going to go ahead and put my light in. And we see we made it even dimmer. So that's something you'll want to play with, just seeing what kinds of things happen with the resistors and the jumpers and all of that. What happens when you stack them, what happens when you change the amount of power you're providing to them, okay? See if you can get a AAA battery to power your LED. See if you can get it to power something that will power a blue LED but doesn't have enough power for a red or yellow LED. Just mess around and see what you can come up with, okay? And finally, we have one last thing. Playing with resistors again, but first I'll put a jumper in. And that is, we have our speaker. Oh, I put that jumper in the wrong place. We have our speaker. You can see our speaker. Oh, let's see. Also has a long lead and a short lead. It also needs to be plugged in. Okay, it is polarized. The power needs to go in the long lead and grounded out the short lead. So I need to get my jumpers in the right configuration. I'm going to get them on 27 and 30. And then I'm going to plug my speaker into 27 and 30. And that's super annoying. Okay? And so we're going to take our 1.2 kilo ohm resistor and we're going to try and make that less awful. Sorry, 2.2 kilo ohm resistor. And now, oh, that's too much. We don't have any power for it. Let's make sure I plugged it in right. Yep. Okay, so let's take our 100 ohm resistor and see how that works. Now, I didn't say this explicitly, but we've been using it like that. These resistors are not polarized, okay? It doesn't matter which direction you put them in the board. And it doesn't matter if you put them on the positive side or the ground side. Can you hear that? It's very quiet. So again, play with your speaker with different amounts of power and different resistors and see what you can get going. See if you can get your speaker and a light working at the same time, an LED working at the same time. Does it matter whether that LED is red or orange? And what else can you find out?